All right, so what's a problem you guys had? Number 4, okay. So on this one, you are going to multiply the numerator and denominator by the conjugate of the denominator. So what is the conjugate of the denominator? Yes. So same real part, but opposite imaginary part. All right, so in the numerator, we're just going to do the distributive property. In the denominator, we're going to do shortcut multiplication. Because they're conjugates, we can just do 3 times 3 and negative I times I. Now up here at the top, we should have filled in that I squared is negative 1 and I is the square root of negative 1. So anytime you have I squared, you're just going to change it to negative 1, which means 4I squared is really just negative 4. And minus I squared is really plus 1. So 9 plus 1 is going to be 10. Now, when we write these numbers in standard form, they're not going to be as one fraction. So it's going to be a real part, then imaginary part. That's why I put the 4 first. But anyway, we're going to put 4 over negative 10. And that's going to reduce to negative 2/5. And then we're going to put 12 over 10, and that's going to reduce to 6/5 I. So that is the official standard form of that number.
So does it have to be the I comes second?
Yes. Yes, it does. All right. What other questions do you guys have? Number 8. Okay. So this is a quadratic equation that we're going to solve. You could try to factor it, but it won't factor because the only way you can multiply and get 11 is 1 and 11, and there's not going to be any combination of those numbers to give you 2. So we have other options. We can complete the square, or we can do the quadratic formula. Would this one be a good one to complete the square?
Yes.
Yes. So because this is a 1 and this is even, that's what I would choose. And so you would just move the 11 over. And then we're going to complete the square by taking half of 2, which is 1, and squaring it, which is 1. All right. And then what should that be inside the parentheses? Yes, x minus 1 equals negative 10. All right. And then we'll take the positive and negative square root. And for the square root of negative 10, really, all you do is just pull out an I because it was a negative and make it positive 10. And then finally, we're just going to move that 1 over. And those should be your answers.
Could you not move 1 plus 2I squared root of 5?
No, that is it. That's what you would get if 4 times 5 was 10. But that's 20. So at that point, you're looking for a square that divides evenly into 10. And there isn't one besides 1. All right. So what other questions do you guys have? Yes. All right. So 17 and 18 are both to divide. Can I do synthetic division on number 17? I can. Whoops. So because I'm dividing by just x minus 2, I can do synthetic. What would I put in the box? Positive 2. Do I need to fill in any zeros? Yes. All right, so once we get all of that multiplied and added, then we're ready to write our function. And so this started off as x to the fourth. So when I do division, what should it be now? To the third. And then we're just going to go down. And then we're going to put our remainder over our divisor. All right, so if there was a question on your test, like after this one, and it says something like, is x minus 2 a factor of that? What would you say? Why not? Good. For it to be a factor, you would need to get a remainder of 0. All right, Skylar, did you have a question? Sure. I was expecting you guys to ask about 7. My third period was unhappy that I put 7 on here. Yes, maybe not this particular question, but we did applications of quadratics for sure. So for A, this one is A part is just evaluating. So we're just going to find R of 16 by putting 16 in for P. Now this isn't super easy to do without a smart calculator. But when you plug that in, you should, I did it by hand, but you should get $2,304. That's just evaluating the function. I don't think you had a problem with that one. The second part might have been where you had a struggle. So it asked for what service hour. So in this situation, R is the revenue earned by computer repair service, given that they charge P dollars per hour. So businesses kind of have to figure this out, like figure out what should they charge per hour where they're making the most revenue or it ends up being the most profit. Because if they charge too much, less people are going to hire them. If they don't charge enough, they're not making enough money. So anyway, we want to figure out what they should charge to maximize their revenue. So where is a maximum going to occur on a parabola? At the vertex. The top of it, if it's upside down parabola, which is what this is going to be at the vertex. So we want to find the vertex. Now I feel like when we did this before, it was like someone was punting a ball or something or hitting a baseball, and the maximum was going to be at the vertex. It hit the ground at the y-intercept or the x-intercept. So we definitely did problems like this. Just don't remember. It's okay. All right, so we want to take this function and write it in vertex form. So the first thing you do when you're writing in vertex form is put parentheses around, in this case, the p's. What's the next thing you do? What did you do on number 5 and 6? Well, we're going to factor out. So if there's a number in front of your p squared, you're going to factor that out. So we're going to factor out negative 12. And that's going to be 28. All right, now we don't have anything outside there, so we're just going to minus something. All right, so we're going to take half of 28, which is 14, and we're going to square that, and we're going to get 196. That's what we're going to add on the inside. On the outside, we're going to subtract negative 12 times 196. All right, so this is going to be what we got when we took half, which was 14. And then negative, or minus negative is going to change to a positive, and then that's going to be 2,352. So there's two parts to this vertex, 14 and 2,342. So which one do you think answers the question? How much they should charge per service hour? The 14. Now, if you can find a job that makes $2,352 an hour, I definitely want that job for sure. $14 an hour. I think this might be an outdated problem. So we're looking at the $14. Sure.
So in math terms, you look at the X values now.
Well, it depends on what it's asking for. So in this problem, we want the price charged per service hour. In this problem, that is P. If it had actually asked for what is the maximum weekly revenue, then you would give the 2,500 or 2,352. You just have to look at what it's asking. Okay. So 15 is all about end behavior or what's happening at the ends of the graphs. So, or the leading coefficient test. So we want to know on 15 if the degree of this polynomial is even or odd. So you look at the ends, that's all that matters for this question. If they're pointing in opposite directions, what would you say? Odd. Even points in the same direction, odd points in opposite direction. All right, then if you're trying to figure out the leading coefficient, you only look at what's happening on the right side. If the right side is pointing up, then we have a positive leading coefficient. If the right side is pointing down, then you have a negative. All right, and then whenever it's asking about multiplicities, that's going to be at the zeros. That's going to be at the X-intercepts. And so we have a bunch of zeros. But when I noticed at those zeros everywhere, it just goes straight through. So what type of multiplicities would that be? Even or odd? That would be odd. For an even multiplicity, it would need to bounce. It didn't.
But so we get a problem like this, and one of them bounce, and one of them goes.
It won't be like that. If it's asking for all of them, they'll all do the same thing. Or it'll say something like, give this zero, what's the multiplicity?
Can you do the 12, 13, 14, and so on?
Okay, for those you have to know basically what I just said here. Those are these questions. So for the first one, we're describing the end behavior, which is what happens on the left and what happens on the right. So because it's an even, it's going to be the same. Even degree is going to be, they're going to point in the same direction. And then this leading coefficient is negative, so they're both going to be pointing down. So you might study the leading coefficient test. All right, what other questions do you guys have? Okay, odd leading or odd degree, like this is the degree 3. Means they're going to point in different directions. Positive leading coefficient means what's going to happen on the right. Rises. Opposite is going to be on the left, so falls. You guys try 14 on your own if you haven't done this yet, or if you don't feel like you did it right. So you see that there's an odd degree, so they're going to go opposite directions. That leading coefficient is negative, so I know it falls on the right. So it's going to do the opposite on the left.
Can you do 25?
Which one?
25.
Yes. I love these. Okay, so 25 and 26 are practically the same problem. So we have to use like everything that you learned about the zeros of polynomial functions and the x-intercepts and y, all of it to do it. So we're going to write a function. So we'll call it, it's already called f of x. So let's call it what the graph calls it. And a is one thing we don't know. We have to find a. So we'll just put a there. All right, and then I noticed this one has 3 zeros. So I'm going to go ahead and do 3 factors. There's a factor for each 0. All right, so the 0 that goes through -3, I'm going to have that factor be x plus 3. Does anything weird happen at -3? Weird is a bounce or a bend. Nothing weird happens, so that multiplicity is just going to be 1. All right, at 2, that factor is going to be x minus 2, but something weird does happen there. So it bounces, so we're going to have that be squared. And then another 0 at 5, we'll have that be x minus 5. Nothing weird happens, so we'll just leave it. All right, now I do need to find what a is. And the only other thing I know for sure is that we have a y-intercept at 0, -2. So that's an actual point on the graph. Now we could do this with other points on the graph, but just looking at it, I don't see where it definitely crosses exactly like that. Possibly could be a point, but 0 is super easy to plug in. So that's what I'm going to put in. I'm going to put in -2 for f of x because that's the y. And then I'm going to put 0 in for all of the x's. So that's just going to drop off the x's. All right, so that's going to be 3 times 4 times -5, which is 12 times -5, which is going to be -60a. And then I'll just divide by that -60. And then that's going to reduce to 1/30th, which is kind of a weird number to be a, but that's okay. So your final answer is going to be 1/30th and then all those factors. So when it tells you to leave the function in factored / intercept form, bless you, this is what they're talking about. I don't want you to take the time to multiply that out. There'll be other problems where you have to multiply it out that won't be as time consuming as that one would have been. And you'd have a bunch of fractions too. All right, what other questions do you guys have? 27. Okay. This is the most recent thing that we've done. So we are going to write a polynomial function. So call it whatever you want to. I'm going to call it f of x. And we know that this function has these zeros. Are these all the zeros this function has? No. What else is a 0? -2i. So remember that imaginary zeros come in conjugate pairs. All right, so we're going to do a factor for each 0. And then this one, the directions are different. It tells you to write your answers in standard form. So we do need to multiply all of these out. So when you're multiplying, you can only multiply two things at a time. So I'm going to multiply these together and multiply these together. You definitely multiply the conjugates together no matter what. Now, the good thing about conjugates, we talked about this, I think on the first one I did today, is you can just do the shortcut multiplication. All right, and then negative 4i squared is really just plus 4. All right, so now we're going to need to distribute x squared. Sorry. And then distribute the 4. Okay, unless I made a mistake somewhere, that should be a function that has those zeros. Yep. So don't forget about the conjugate pairs on that one. Okay, what other questions do you guys have?
Wait, before you solve it, since it's such like I guess like tedious math, is there a way we can like check ourselves on that? Or like how do we?
I mean, if you wanted to, you could go back after you're done. I don't know if you'll have time tomorrow because it's a shortened period, or you're doing yours this afternoon, and do synthetic division with 3 and -1. Check it that way. Make sure you get a remainder of 0. And then do long division with, oh, I didn't mean to erase that. Do long division with that one and see if you get a remainder of 0. That's the only way to check.
I think I'm right.
Just show all your work. Make sure you show all your work because I like to give you as much partial credit as possible. So if you just make one little mistake, it's not like you're going to miss the whole problem.
If you were to just check with one of those up there, just to give it like a brief, am I possibly right?
I mean, it'd be better than not checking at all if you have time.
Well, if 3 is a 0 of it, wouldn't that mean that like?
No, because you could have made a mistake multiplying somewhere, but 3 would still work out. But I mean, if you want to do it, if you have time, sure. Okay, let's look at, what number was it again? I'm sorry. 23. Okay. Possible rational zeros. The stuff is still on the wall. So this is the P's and the Q's. So we're going to do, P is going to be, oh, I don't do it there. P is going to be the factors of the constant. Which is going to be 9. So all the factors of 9 are positive and negative 1, positive and negative 3, and positive and negative 9. All right, and then Q is going to be the factors of the leading coefficient. Positive and negative 1 and positive and negative 2. But the actual answer to the question, and this I'm pretty sure is a multiple choice question on your test. So the answers you're going to look for are the possible rational zeros are the P's over the Q's. It's a weird looking Q. All right, so I'm going to take all of these light blue ones and put them over 1, which will give you that same list. And then I'm going to take all these light blue ones and put them over 2. That's the list we're looking for. All right, what other questions do you guys have? Yes. Sorry.
Like on 25, what is the, I don't get what the 130 is.
The 1/30th? That's A. It's just a factor that
I'm saying like,
I just did that one. You set it up and just make it an A, and then you plug in the y-intercept. So you do a factor for each zero, and then you plug the y-intercept for the zero in for x and the y-intercept in for f of x. All right. Kaylin, did you have a question?
Could you do 21 or 22?
They're almost identical, so it doesn't really matter which one. Now, these, and I think I told you about it when we did this before. So on topic 5, on these finding the zeros, if you can factor it, you want to factor it. So that's what you do on 19 and 20. But when you get to 21 and 22, like you could try to factor by grouping, but then you notice that there is just not going to work. I think. No, it's not going to work. So what you'll do instead is do synthetic division to find 1 0, and then factor or solve what's left over. So the way I wrote the answer choices was hopefully it will be obvious to you what number you want to do synthetic division with. Otherwise, you're not going to have time to figure it all out just because there would be so many possibilities. So obviously on 21, the 0 that's going to be the real 0 is 5. So just go ahead and put 5 in the box because all the answer choices have it. It has to be it. All right, and then that leaves you with a depressed polynomial that we can solve. Now, it's not going to factor, and you can kind of look at your answer choices and know that it's not going to factor. When it factors, your answer choices are like 2, -5, or whatever. So we're going to solve this one similarly to what we did on number 8. It's very much like number 8, actually. Or if you don't like completing the square, you can do the quadratic formula. It's up to you. So same thing like we did on that one. We pull out an I. And there's not a square that goes into 6. So we just leave it, the square root of 6, and then move that 1 over. So that's going to be 2 zeros, 2 imaginary zeros. 5 is the other 0. So that looks like B to me. Be careful choosing those because those answer choices are so similar. It's easy to do everything right and then just pick the wrong choice. Sure. Okay, so we want to factor that. Well, we set it equal to 0 and factor it. So the first thing I notice about it is they all have x cubed at least, and they're all even. So I'm going to factor out a common factor of 2x cubed. And then again, factor again. And then we figure out what makes each of these equal to 0. So it's going to be 0. What? This question doesn't ask this. But let's pretend it did. If it asked what the multiplicity of 0 is, what would you say? 3. So because it has this power of 3, we're going to say multiplicity of 3. All right, and then the other 0 is 4. What would you say its multiplicity is? 2. This question did not ask that. I just wanted to throw that in there. So if you were going to graph this, there'd be like a little bend at 0, and there'd be a bounce at 4. All right. What other questions do you guys have?
Can you explain like number of
All right, that's the same thing we did here. So, and this one. So we knew that 3 was a 0 of the function. So what did we say was a factor of the function? If 3 was a 0, what was a factor?
X?
X minus 3. So it's the same thing. So if 6 is if 6 is a 0, then what's a factor? Yeah. Okay. What other questions do you guys have? Okay. If 6 is a 0, what is an x-intercept? If 6 is a 0, where is it going to cross the x-axis? At 6, 0. Is that what you said? That's not what I heard. It might have been what you said.
I just meant like the other one was 0.
Oh, no, not necessarily. Oh, the other coordinate? Yes.
Yeah.
Okay, sorry. All right, and then if a function has a degree of 5, what is the maximum number of turning points? That's something we haven't talked about in a while. Yes, so it's 1 less than the degree. And then the zeros, the number of zeros should match the degree if you're talking about real and imaginary. All right, what other questions? Okay.
We ever heard of continuous square? But you don't put them under the get when you square it. Right?
In the parentheses? Yes. Any other questions? We've done a lot of each different type, so that's good. Okay, so I'm going to give you guys, or not everybody has to take it because I don't think I made copies for everyone, but if you want it, you can take it. I have an extra credit review that is like a shortened version of this review. Like on this review, a lot of times I did 2 problems that were similar for you to practice. The extra credit review is shorter. If you want it, you don't have to take it. It won't hurt my feelings.